This one, we were able to fit the whole thing on the screen here. Let me just kind of talk through this thing quickly. When you graph this one, it looks like that, but notice it says it's bounded above, which means there is a ceiling to this thing. If you're going to do this area top curve minus the bottom curve, it's not going all the way up to infinity. If you notice that equation has a 20 in there, so if I plug in x equals 0 right there, my y is equal to 20. So if I just change the window and I can make the y max, I'm going to put it up at like 25 or something like that and then graph it. And then you do see it has a top part and a bottom part right there. All right, so there's the equation. I knew y equals 2 is a horizontal line. So there's my top curve, there's my bottom curve. So when I do the area, it shows top curve minus the bottom curve. And then for this entire problem, you can either integrate from -3 to a +3, or you can go from 0 to 3 and then double that. I think for all of these here, I went from 0 to 3 and then I doubled it. If you're on the no calculator part of the test, you probably want to go with that. But since you're on the calculator part, it doesn't really matter which one because you're going to math 9 each one of these things anyways. Now, as you look at this thing here, is if I trace it, and if I graph like the y equals 2 line on top of there, it looks like we can eyeball this one to get that intersection point there. So I mean, if I trace it, it looks like that's at x equals 3. And if I type in 3, it does give me y is equal to 2. And then if I type in -3, it does give me y is equal to a +2. So there's the intersection points right there. Without the calculator, you could set the two equations equal to each other. It says the y is equal to 2, so you could set that equal to 2. You can solve that equation, get your x equals ±3 that way. But for part A is just area top minus the bottom, go 0, 3, and then double it, math 9 that thing. For the disk method and the volume stuff, we're going about the x-axis, right? So your rectangle is in there perpendicular to the x-axis. Remember, your capital R is a distance from your axis to your farther edge of the curve. You're measuring from the x-axis up. That's always your y variable, and that farther edge is your equation. Your little r is the distance from your x revolution to your closer edge. So from the x-axis up, that's just 2 units every single time right there. And then so you have your capital R squared minus your little r squared. And then the pi was out in front because that was my disk method. And you either go from -3 to 3, and it's just a pi out in front, or since I'm going from 0 to 3, that's just this region here. You need the whole entire region right here. So I went from 0 to 3 and then double it, math 9 that to get that answer there. And again, you have to show your setups. You got to show what your integrals are and then go straight to the math 9. This is like your work, your justification, and then that's your answer. And that's going to help you out anyways, because if you bump something wrong on the calculator, you got all your correct setup there. All right, now for the semicircles, for the cross sections, it says perpendicular to the x-axis. So we draw a little line segment in there, perpendicular to the x-axis, and you find the length of that s, which is going to be top y minus the bottom y. So that's our equation minus the 2. Now remember, when you're doing semicircles, that's the diameter. And on all the cross-section problems, you integrate the area of your cross-section shape. So you're supposed to integrate the area of a semicircle, which is pi r squared divided by 2. This is your diameter. Your s is always your diameter, so you got to cut that in half. So if I divide everything by 2 there, cut that divided by 2, did that divided by 2, there's my radius. And then so I'm going to go pi times this r squared divided by 2. That's the area formula for a semicircle. And then I went from 0 to 3 and then doubled it. That's where that extra 2 came from. And then I typed all that into the calculator, did the math 9. So I'm sure we can figure it out. And again, if you need help with the graphing calculator part, watch the graphing calculator video, but you should be able to math 9 all of those and get all of those answers. Barbecue sauce.